Okay, chapter 11. Name is chapter is cryptographic hash function. There are three sections in your course: 11.1, 11.5, 11.6. First, we discuss about the hash function. Now, our basic definition: what is a function? Then we come on hash function. You know about very well about the function, a rule, yeah, association between two elements. Say f is a rule from set A to set B. This rule defined as y equals to fx. This is a function. This part is known as the domain. This part known as the codomain. If all the element lie, the image of x lie in B, then it's called a range. You know very well about that. Okay. So our basic definition, we write as example of the single valued function. If we take a define a function like that, A cross B to C. So your input say is x, y equals to z. So here x from A, y from B, and z from C. This is multi-valued function. Okay, yeah, two-valued function because the input is more than one quantity and output is one. Okay, so similar approach and hash function. Hash function is the function which convert variable length string to finite length string. Means uh, you would know it like that. You see this diagram, okay? I write this diagram. This is the hash function. Function is machine. You input as I say different inputs. Okay. Then operate this h. Then output say is a single value. Say is x1, x2, x3. Say is one. So here simply we write here h of x1, x2 up to xn is equals to 1. So here this x next to is the bit length of a message, the length of the string. To see right here, the concept is x equals to x1, x2 up to xn dot dot. This is the variable length of the string. Okay, you operate here has function say x. This x. This is operate. Then we find a finite length of a value. Okay. So means cryptographic hash function is a function which convert arbitrary length of a string into finite length of a string. Okay. So arbitrary means we not define the length of the string. Okay. Yeah, or length of the plain text. This is the basic definition of the hash function. This virtually the cryptographic hash function involve iterative use of the comparison function. Okay, this is a iterative approach we are using in the hash function. Now, the kind of the hash function needed for the security applications is referred to as a cryptographic hash function. So means the role of the hash function in cryptography very broad. It maintain a security and privacy in communication system. From my side, I'm working on authentication and signature protocols. Recently, I'm working on authentication, authentication, and signature protocols. In two directions, the hash function involve properly and maintain the security and privacy of the authenticity of a user with the help of a signature. uh, which the meaning of signature is a digital signature. We will discuss about the uh, signature protocols in chapter 13. Okay. Now the basic idea about hash function. Okay. The hash function is operate here the series diagram. Your message is plain text or data block in envelopes. Then length is sum. When you convert a length is L. You operate here hash function, then convert this hash value is a fixed length string. If the length is arbitrary of this message, the converted length is a fixed of the hash value. Okay. So there is no confusion here. You operate here hash function on x1, x2, x, and this is a arbitrary length of the message, the arbitrary length of a plain text, या of a blocks of plain text. Then convert is value is say simple value is y. That is convert a variable length string to finite length string. So this is a hash function. Okay. Now the basic requirement of the hash function is this. They are the only three and four requirement. Okay. Say first requirement is H can be applied to a block of a data any size. Okay, this is requirement. Again, H means has concerned produce a fixed length output by definition. Third is Hx is relatively easy to compute any given value x and making both hardware and software implementation practical. And fourth one is this is one-way property. Is provide a one-way property. One-way property means for any given value x, it computationally infeasible to find the value of this. Meaning say, this if you have a input x and output your hx. Okay, so this is easy. For this value, for this value hx is output, it is not easy to find this x. Means in a communication system, if Alice send a message to Bob, say x, with the help of hash value here. Okay, so attacker not access the value of this x. This is a property of number. Okay. Second, V collision resistance. Okay, this is a good property of the hash function. V collision resistance for each given block X, it is computationally infeasible to find Y not equals to X such that Hx equals to Hy. As this here, if we have a two outputs, say Hx and Hy, in a hash function, it is not easy find which is hard, to compute x and y. So means for a given value hx and hy, it is not easy find the value of x and y. Okay, this is a hardness property or weak collision resistance property of the hash function. Sixth one is strong collision resistance. Okay, so it is almost same, but here we choose the pair of xy. Okay, means for a given value hx and hy, it is not easy, yeah, completely hard to find the pair of xy. Means for a given output is not easy compute to xy. So what is the difference between two property? This property phi based on the two arbitrary input hxxy corresponding output hxxy and the corresponding xy. X not equals to y, but in this six property, this xy is the pair of input. Okay, so last year this question involved in your exam. Okay, this question involved your exam. Actually, last year I was the member of the paper study committee, so I have discussed about these questions. I provided one question theoretical and one practical approach. The only simple basic concept of the hash function. Okay, So for the exams, this is a very important chapter for you. Okay. So see, this is a comparison requirement of the cryptographic has concerned. The same approach right here in the previous uh, section. Okay, the requirement and decryption. We already discussed all these things. These variable input size. So H can be applied on a block or a data analysis. We already discussed it. Okay, fixed output size. It's almost same. Efficiency. This efficiency means HX relatively easy to compute for given value X and make a both hardware software implementation of practice. Okay. And the pre-image resistance means one bit property for given H value H computationally infeasible to find Y such that. Okay. The second approach, weak collision resistance, we already discussed to you, and collision resistance means collision means strong collision resistance. Or last one is a pseudo randomness. The output means standard test for the pseudo random number. We already discussed to you pseudo random number, which are the number near about to random number. Okay. These are the basic property of the hash function. Okay. Now, these are the applications of hash function. Okay. Other things we will discuss in tomorrow class. Okay. Now, you learn about this about the hash function with the help of your book and some Google. Okay. Then tomorrow we will discuss about application of the cryptographic hash function. Okay. This is new idea about the hash function. I've discussed here only basic definition of the hash function, property of the hash function. Okay, and how to develop the area of the hash function. Okay, these are simple properties. Okay,